Hey, what's up? All right, another devlog video. Hopefully you guys will enjoy it. I got a little bit of secret sauce, some stuff I've been working on. It's nothing crazy, but I think it's interesting. So I've been playing around with. I've been trying to figure out what to do about like interpolation. Um, so this video is actually I'm actually in the editor today. I'm not. I don't have a regular executable build because I'm going to play around with some stuff and I actually want it to be glitchy because we're going to be talking about interpolation a little bit. We're going to be talking about timing of like the render timing versus the physics timing, and why that's important, and some decisions that I'm trying to make with regard to how I want to do things moving forward. Because I thought that I was going to run a fixed physics rate of 120 frames per second and then interpolate the rigid bodies, or interpolate the transforms of the rigid bodies so that everything's nice and smooth regardless of what render rate your headset is set for. But I don't know. I was running 120 render rate and 120 physics rate and not realizing just how bad some of the interpolation was. So if you're not familiar, interpolation um, makes it so that, well, I've got some visual aids here. Maybe this will help a little bit. So the googly eyes, that's a render frame, or that's a render, and the little cube that I've got here, that's a physics update or a fixed update. Um, I'll refer to the googly eyes as either render or update because I'm using Unity, and I'll refer to the cube as either fixed update or um, or physics, one or the other. So I want my stuff to be smooth, and so to make things smooth, you're probably gonna want like a one-to-one physics render, physics render, physics render, physics render, or even n to one, where you've got like double physics and then a render, then double physics, then a render, double physics, then a render. And I actually used to do even like when I was running a CV1, I was running like triple physics, 270 on the physics and 90 on the headset for a 3-to-1 ratio. Looked fantastic, felt fantastic, but that's not going to play for like the Quest or whatever. So I'm trying to drop my physics rate down, and I would like to support like 120, 120 would be my favorite. But then again, 144 on the index looks like freaking fantastic also. So it brings up an interesting question: is how do you support all these different render rates and still have the physics work well? And it's a tricky challenge. You either have to interpolate so that you don't have like judder in your movement as the physics differs from the render, or you have to match. And matching has its own problems because matching like I mean like one to one, where you've got like if you're running 120 render, then you're running 120 physics. That's problematic also because the joint character, like configurable joint characteristics, and various other things have physics rate dependencies. A joint, like a spring joint, bouncing back and forth, is going to have different characteristics when it's running at 80 physics versus 120 or 144 physics. And I wish that wasn't the case, but I've tested it extensively, and it is absolutely the case that those things will act differently from each other at different rates. So I'm at an interesting dilemma. Do I try to figure out how to make physics props and the body itself operate at various physics rates and be smooth, which might require completely different tuning on all physics props, or come up with some fancy way to adjust the properties so that it can deal with a variable physics rate at any point in time. I'm not exactly sure how I'm going to do all of that. But one thing I am pretty sure about is that I'm going to try to make it so that the character and the physics props are all physics rate independent as much as possible, because as awesome as interpolation is at trying to smooth things out when your physics rate and your render rate don't match each other, it's still kind of terrible, and uses extra calculations on top of that. So if you can do a nice one-to-one, then you can actually avoid interpolation altogether, for the most part. Um, there are some issues even with doing that. I don't really want to get that deep into interpolation. What I want to talk today about is smoothing, making everything just really, really smooth. So the physics rate is going to run at whatever rate it's set for, and that's the game time, and it runs consistently. It's rock solid, because even if your computer was slowing down, well, the game would slow down. Like in real time, the game would slow down, and the game time would still be consistently spot on for the physics update or the fixed update. It's you set it, and then it ticks away at whatever interval that it's set for. So that's not so much the issue. The issue is when it renders. So Unity has to guess when it's going to start preparing the render, and each frame doesn't necessarily take the same amount of time. So maybe it uses calculations from the previous frame to help calculate how long it's going to take to do the next frame, and maybe it knows how complicated the scene is and how many things are in it and factors that in as well. But at the end of the day, what's going to happen is that your render is going to have a little jitter to it, right? It's not necessarily going to be in the same spot, even though you want it to be. Like your physics rate, bang, 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 bang. It's gonna be at a constant interval. But this render, maybe you've got one that comes a little early, and maybe you've got one that comes a little late, and then a little early, and then a little early. Like you don't know exactly when that's gonna happen. Now, as long as this render happens in like if you're trying to do a one-to-one, as long as this render happens in between your two fixed updates, it's probably not that big of a deal if it slides around a little bit, right? You're not really going to notice. I mean, technically, if you've got super crazy, awesome eyeballs that can sense that this render came literally like 1 or 2 milliseconds early, um, maybe you do want interpolation, but most people aren't going to be able to tell that. It's still going to look smooth, even if it's a millisecond or two off, right? So that's not that big of a deal. What when it becomes a real problem, is if the render overlaps the physics rate, right? Because if this slides over here a little bit and then slightly crosses, then we're going to have a double physics and then a render, or a double physics and then a double render and then another physics, or whatever. In any case, you're going to have a double of something, and that's going to come across visually as a glitch in the movement. It's going to be nice and smooth, and then you're going to be able to see it, if you're looking for it. And if you have a lot of those, then it's just going to look like your movement is just not nice and smooth all the time. And that's what I'm concentrating on fixing in this particular case today. So some of the developers that I hang out with, one of them had a really good method for averaging the render time out, over a bunch of frames, and then adjusting the physics rate accordingly, so that if the render times were all a little bit slow, then the physics would slow down a little bit to match. And that does a really good job of keeping the rendering consistent from one frame to the next. But it doesn't address a problem that I've noticed. I've got some visualization that I'll show in just a minute, which makes it apparent that there's something else going on that's causing a problem. And again, that's when we get close to this line here. When we get close, so let's say this is so let's forget about these for now and just worry about this one render right here. So we want it to be in between the lines, in between the physics updates or fixed updates. And we don't know exactly when it's going to be. And from one frame to the next, it's actually going to appear to kind of jiggle back and forth a little bit um, as it shows up at slightly different times from one frame to the next. And if this is in the middle, that's no big deal. But if this gets close to the line, then it's a problem if it crosses. And if it's jiggling, right? If it's jiggling and it's near the line, then it's going to cross and cross back and cross and cross back and cross and cross back. And you didn't just have one event, you had several visual events that happened at that point in time. And that's not good. Because again, it's not going to be nice and clean and smooth movement. It's going to be not smooth, right? With little jitters or judders or hiccups or whatever you want to call it. So my thought is, why don't we try to control where this is in between these physics updates? And the method is actually really, really simple and it appears to be really, really effective as well. So let's say this is in the middle. I don't have to do anything. It's in the perfect place. It's already in the middle. So if it comes a little earlier, if it comes a little late, it's no big deal, right? I don't really have to do anything. But as this begins, so let's say it's jittering back and forth and it begins to approach the line over here. What I want to do is make it so that subsequent physics frames stretch a little bit longer, right? And what that's going to do over time is it's going to force this back to the middle. And if it's in the middle, then I've got this buffer zone where it can be a little earlier, a little late, and it's no big deal because I've got this nice buffer. I just want to keep this away from the sides, right? So, and it's just that easy. If this is if this is coming a little bit early and I think it's encroaching upon this line, then speed up the physics and push this back to the middle. If this is coming a little bit late and it's encroaching on the line, then slow down the physics and it pushes this back towards the middle. It's simple. And in hindsight, this seems like a really obvious solution that's very easy to implement. Like really, really easy to implement and really, really effective at preventing this situation where we're jiggling back and forth across this line and it's causing visual issues that you can see, judder with the hands, or hiccups in the movement, right? And so that's what I've done. And so today I'm in the editor instead of in a normal build, and I can tweak some stuff in the editor. And also the editor is known for being kind of kind of crappy. At rendering, it's got a lot of lag and it has like hiccups and stuff all the time. So hopefully we'll get to see some of those. And I'm going to switch over. I'm going to switch over to first person and show you what I'm talking about. So I've done some visualization here. This is I've set up some particles to display what's going on with the fixed rate and also what's going on with the update, the render rate, right? So the jitter that you see here in the green, this is when the rendering is happening. And this line over here is like 0. This line over here is 0.0833333 because we're at 120 frames per second for both the render and the fixed rate, right? So this is normally going to sit wherever it's going to sit and it's going to try to stay in the same place most of the time, but you can see it doesn't. Like every once in a while it just kind of freaks out and moves somewhere. And as far as I know, there's not really any mechanism that Unity's doing to keep this in the middle. It doesn't necessarily want to keep it in the middle, but I'm running some code that's doing correction on the fixed rate to try to push this back to the middle so that it stays away from the sides. And you can see right there that curvature is the code that I've got that's pushing it back over. Because otherwise, when it got close to the line, it would just stay there until the next time that it just flipped out and went to another place. It would normally just kind of stay. And here, let me turn it off for a second, and you'll kind of see what I'm talking about. So Give me 1 second. I'm switching out to mouse and stuff. Monkeying with this. Okay, so here I've left the inspector visible with inspecting an object, and so you can see how the editor is now kind of crappy. We don't have a consistent, um, we don't. It's not super consistent with regard to the render rate. I guess I didn't really explain what I've got going on here. So there's a few things going on here. So we've got the zero, which is this line over here, and then I've marked out like where like 144 frames per second would be, and where 120 frames per second would be, and where 90 frames per second would be. Basically, this is acting like a clock that measures the amount of time between the last physics update and the current render, the current update, right? The amount of time that's passed. It just measures that and then converts it to a length. In this case, it's doing like 100 times. So if 120, 1 over 120 is like 0.083333, whatever, then this is multiplying that by 100 and ending up with 0.8333 of a meter. And so that's kind of what that's doing there. Anyway, so I've turned off the smoothing that I've got and left the inspector inspecting something, and you can see that this thing's just all over the place. It's rendering at various times. It's just kind of skittering back and forth, and then I've got some big cubes here or big squares here, and that represents when like a render frame is too long and essentially gets lost, or is so short that it's like two renders in a row with no physics in between at all. So that's I hope that's a bad explanation, but I hope you guys understand what's going on here. Essentially, I came up with this when I was playing around with interpolation, and I noticed that interpolated objects were making some wild swings whenever I had like a bad frame rate event. Maybe I had a browser update or something that like the computer was multitasking or doing something, and that was causing this like big glitch. And I was like, well, if interpolation makes a glitch, then I could actually make a clock out of that. And so then I built I call it an interpolation clock, where I had an object that was flipping back and forth between 1 and -1. And it was an interpolated rigid body, so that it wasn't 1 or -1. It was between 1 and -1, based on when the refresh happened in between the two changes. Doing that with an interpolated rigid body is completely unnecessary. You can just measure the amount of time, and I verified that by setting them both up at the same time and watching them and making sure that yeah, in fact, they're pretty much measuring the same thing. So to me, this is here. Let me actually improve the view here. Okay, so I took off the inspected item. It still looks really crappy though, because we're riding the line over here. So again, when you're riding the line, you've got a whole lot of render physics, render physics, instead of render physics. Okay, so all right, I feel like I'm starting to ramble here, but hopefully you guys are following what I'm trying to do here. So now the smoothing right now is off, and so this guy's just going to kind of jitter around and flit around wherever he wants to go. He's always going to be in between the zero and the physics rate, but he's going to jitter around in here and go various places and stuff. And when he hits the line, he's going back and forth, and it's just an ugly kind of thing. And maybe I'll try to move my hands a little bit as well, and you'll see, like right now, the hand looks really, really smooth. But whenever you see an event like that, where the green dots are just all over the place, then you're also going to see that's going to correspond with a jitter in the movement of the hand, as I'm moving it around. So hopefully we'll get some cool events. Like I saw that one. Hopefully it came across on video. So I'll just kind of move around for a second, and maybe we'll get some cool events. Maybe we won't. I don't know. So right now it's looking pretty smooth. I saw that one. So there was another one. There's a whole bunch going on right now. Here, let me keep moving. You can see the hand jittering. Yeah, we're riding the line right now. There's a lot of jitter that's associated with riding the line. So again, it's not fixing a horrible problem. It's fixing a really, really minor problem. But once you're used to looking for this stuff, you really start to notice it. Oh, that was a bad one. Okay, so again, what I'm trying to do is keep the green in the middle. Here, let me mouse over here and turn the smoothing back on. Okay, so the smoothing's back on, and it's going to pull this back towards the center here so that there's a nice buffer zone, and it stays away from the fixed updates, and we don't have a crossover. So here you can see that curvature right there. That's me pulling it back over with the code that I've got. Pulling it back over. So now down here you can see following the jittery cube, there's a smoothed cube. And that's just a linear interpolation, a lerp on the jittery one to try to smooth it out. And then the smooth cube is being the position of the smooth cube, or the value of the smooth cube, is just being passed into a an animation curve to get a value for affecting the fixed rate, to either slow it up or slow it down or speed it up, depending on how I want to move where the render is, right? And so you probably haven't noticed this move at all, and that's because I barely do anything. You can maybe be able to see just a tiny little wiggle in there where it's just barely moving. I mean, by barely, I mean it's probably not even, it may not even be getting to like 119 instead of 120. I mean, it's just barely moving. So what I'll do, I'll go over here and modify that. So I'm going to increase it by a factor of like 10. And you should be able to see it more aggressively moving around. You should be able to see it now moving the fixed rate more aggressively and really pushing it towards the middle. So if we have some more events, I'll try to point them out on the red line. So hanging out, try to move a little bit. Maybe I'll cause something to pick something up, maybe cause some render events or whatever, some slowdown, some lag. There we go. There was one. And you can see the waviness there where it's using the physics rate modification to push this back towards the middle. So that was an ugly one. And again, just always trying to push this back towards the middle. And you don't have to be super aggressive with this because, like I said, we're not trying to correct the anomaly that happened. It happened. It already happened. It already made this, it already made a glitch, a hiccup in the movement, and there's not really anything that we can do about that. Like I said, it already happened. What we're trying to do is get the render back to the middle so that it has a buffer zone, so that the next time there's some anomaly, it hopefully stays within the lines. That's what we want, right? And so right now, there's no events going on, and you can see the movement. Oh, there was one. The movement is just nice and smooth, really, really clean. No hiccups. Well, there was a hiccup. So, and again, I actually want these hiccups because I want you guys to be able to see visually what's happening, and that we've captured it in the visualized data here. And this is another thing that I really like to do is try to visualize as much as I can. When you've got an issue that you're trying to solve and you're not exactly sure how to go about it, and you're not exactly sure what the data is doing, and you're just throwing solutions at it one after another to see what sticks, I really like to try to visualize the data and understand how, like what's going on, so that you can make a better solution, and then you can evaluate that solution. If I've got nice clean visualization to look at, I can go, oh, I understand this pattern, and I understand how to, like for example, I'm using an animation curve based on the positioning of of the smoothed cube down here, or the value that corresponds to the smooth cube. That animation curve is very specific to how I want to move this back towards the center. I want to be a little bit more aggressive on the ends, but in the middle, maybe there's kind of a dead zone where it's fine to kind of float around in the middle without being corrected at all, because I don't want to overcorrect the fixed rate. I want it to be at 120 as much as possible. And when I do correct it, I don't want to correct it aggressively. I want to correct it just a little bit, and do that until we're square, if that makes sense. So again, if you're having trouble with an issue, a lot of times it really, really helps to just visualize that. Visualize your data, look for patterns, find a solution, try a solution, visualize your solution, and then see if it's actually working. So anyway, that's my process. So I don't know how helpful this has been. I think it's a neat little trick. You guys try it out, see if you like it. It's like I said, it's super simple. You're just measuring the amount of time between the last fixed rate and your current render rate. I've got a little bit of smoothing in there, and then I'm feeding that into an animation curve, which then modifies the fixed rate accordingly. I'm stretching it out a little bit longer or shortening up just a little bit to pull that render back to the middle. And that's it. So that's all I wanted to do today. I wasn't really trying to, there's no IK or physics, anything. Just talking a little bit about smoothing and data visualization. And hopefully that helps and gives you a little peek inside how my brain works and how my problem solving process works. So maybe you liked it, maybe you didn't. Hopefully you did. And if so, give me a comment or try it out and let me know how it works for you. Anyway, talk to you later. Next video. Take care. Bye.